another version of it, which is bottom-up quality control. You start a website, you are selling some product, you are selling books or whatever, and you're asking people to rate the books, and you have a board of experts that read all your books, and there are editors, and they're wise, and they're learned, and they write your book reviews and recommend which one should be what and which one's not, and you get this very successful business going so that you're selling more and more different kinds of books, and as a result, you need to hire more and more of these experts to read the books and produce their ratings, and eventually that just becomes too top-heavy. And what do? The whole world that we completely take for granted now, you have bottom-up evaluations. Everybody rates things, and that's the world where you punch in a book into Amazon, or you look at something in Netflix, and when you return it, it will give you people who liked this movie tend to like these things as well. There are no critics, professional critics, sitting there doing top-down evaluations. This is another realm of expressing attraction and repulsion rules. I liked this, I didn't like this, and all you need to do then is throw in elements of randomization, and you've got bottom-up quality control. And that's a completely different way of doing these things. What's the greatest example out there of bottom-up systems with quality control? Wikipedia. Wikipedia does not have gray-bearded silverback elders there writing up the Wikipedia knowledge and sending it on down to everyone else. It is a bottom-up self-correcting system. It is very easy to make fun of some of the stuff that winds up in Wikipedia, which is like wildly, insanely wrong. But when you get into areas that are fairly hard-nosed, very interesting study about 5 years ago that Nature commissioned, which was getting a bunch of experts to look at Wikipedia and to look at the Encyclopedia Britannica and look at the hard-nosed facts in there about the physical sciences, the life sciences. And what you got was Wikipedia was in hailing distance of the Encyclopedia Britannica's level of accuracy. And that was 5 years ago, and it has 5 years of self-organized correction since then. This is amazing. The Encyclopedia Britannica is like written, there's like 30 like elderly stuffed British scholars that they like have locked in a room for years who produce the encyclopedia, and these are the lawgivers and the knowledge, and you just let a whole bunch of people loose with somewhat differing opinions about whether Madonna was born in 1994 or 1987 or whatever it is, and you throw them all together and you do wisdom of the crowd stuff, and out comes a self-correcting, accurate, adaptive system with no blueprint, just with some very simple local rules. Very simple ones, which is looking for similar patterns shared between different individuals and self-correcting. Where you get even more efficient versions of that is with a lot of websites where not only does everybody get to put in their opinion, but people whose opinions are better rated have more of a voice in evaluating somebody else. You're putting in weighted wisdom of the crowd type functions in there, and out comes incredible accuracy. These are great. There's one drawback with those systems, though, which is with ones like Netflix, where it tells you you're going to like this if you like this, that sort of thing. It's a system that's very biased towards conformity. It's not good at spotting outliers of sort of taste and such. What you really want to do in those systems is, here are the movies that are out right now. Here are the ones that have 10% of the people think it's the greatest movie they've ever seen, and 10% think it's the worst movie. That's an interesting movie to see. That's when you want to be able to get away of bottom-up information about the extremes, movies that generate controversial. Everybody's going to love whatever it is, and that doesn't take a whole lot. This is a way to break the potential for conformity in these bottom-up systems. Nonetheless, overall, it winds up solving a problem without professional critics, without a blueprint, without top-down control. So how do you wire some of these up? Back to the cortex and the adult cortex, and has these power law distributions, and they're great because they optimize. They've got lots of stable local communication, but there's still the ability to do creative long distance connections. So that's great. But how do you get that? How does the nervous system wire up this way? And it does swarm intelligence. The developing cortex does a swarm intelligence solution. When the cortex is first developing, what you will have is a first generation, a pioneer generation. A pioneer generation of cells, the cortex surface, all of that there's a pioneer generation of cells that basically grow processes up like these. And these are called radial glial cells. What they are, they're the ants with the first generation of setting down the trail here. They're the first bees coming in, and what you then have, the neurons, are the second generation random wanderers, and what they do is they come in, and as they begin to develop, they have rules that when they hit a radial glia, they grow up along it. They migrate along it, they throw up connections, and you do that with enough of the cortex, which is hundreds of millions or billions of neurons in there, and you get optimal power law distributions. All you need are some very simple local rules, and out of that emerges an optimally wired cortex. And it's the same simple emergent stuff going on.